So before going to start the coding part or understand with the help of Python coding this iris dataset, so we have to understand that some basic knowledge of the cluster analysis, right? So this is the problem of clustering analysis. So what is cluster analysis and all the things that I'm going to understand. So I hope you can see my screen is visible and you can see. So this is the types of clustering. So first we have to understand how many types of clustering is there, right? And what is clustering, right? So we can say a clustering is a set of cluster. Okay. And in a better way, we can say that cluster analysis is a type of unsupervised machine learning method. It's one of the method, and it is used to group similar objects or data points into cluster. Okay, so cluster analysis is a unsupervised ML method. So we can say it's a type of unsupervised machine learning method, and it is used to group similar objects or similar kind of data points into our cluster. And why it is needed? The goal of clustering is required or is needed. We have to inherit the patterns or structures in the data. There is no defined label. There is no predefined labels, right? So in the data without predefined labels or categories. Okay, so it has the clustering that we can say it's an important distinction between the hierarchical and partition clustering. So this is the some kind of key points of clustering analysis. So first, unsupervised learning, we can say clustering is an unsupervised machine learning algorithm or technique, meaning that the algorithm does not rely on the label data, because we all know unsupervised machine learning algorithms, we should not provide any label data. Data will be clustered or grouped from the machine itself. Machine will be identify how many clusters they will provide according to the data points or data sets, right? So we can say it explore the inherent data structure, or you can say structure of the data. There is no predefined categories. And one of the main points is that the features, or you can say about the clustering analysis, that is similarity based grouping. Okay, so first is unsupervised learning, second is similarity based grouping. So clustering algorithms group data points. So I can also write these things. So clustering algorithms group data points based on the similarity, or you can say proximity, right? So before going to understand all the things, so first we have to understand that some key points, right? So data points within the same clusters are more similar to each other than to one of the clusters, right? This is the similarity based grouping. Another similar points we can say the objectives. The primary objective is to create that we can say the homogeneous clusters, same kind of clusters where the data points within a cluster share common characteristics or properties, right? And types of clustering, we can say partitioning clustering and hierarchical clustering. So what is the partition clustering? A division data objects into non-overlapping subset or clusters, right? So such that each data object is an exactly one subset. So we have to create one subset. We can divide the data into distinct non-overlapping subset, that is k-mean clusterings, right? So partitioning clustering. Another is hierarchical clustering. So hierarchical clustering, what is that? It builds a hierarchy of clusters. Hierarchy of clusters forming a tree-like structure, right? Like dendrogram. It's one of the example of hierarchical clusterings. And how we can understand the metrics, the quality of clusterings, we can say we can result can be assessed using metrics. There are many kind of metrics is there, like silhouette score. We can use the Davis Boolean index or within cluster sum of square. These are the metrics. Okay, so these are type of clusterings we can understand. Next the partition clustering, right? So you can see the original points. These are the original data points. Okay, and we have to create the partition clusterings in this way, right? Say is an example of partition clustering. You already told the partition clustering divides the data into distinct non-overlapping subsets, and origin, you can say there is no label and there is no grouping, right? This is the original data points, and we have to group with that partition clustering. So simple way divides data into distinct non-overlapping subset, that is the partition clustering. This is one of the structure, we can say the diagram. So partition clustering. And second is that hierarchical clustering. I already told, right? Traditional hierarchical clustering, there is two methods: traditional hierarchical clustering and another one of them the traditional dendrogram. So what is the traditional dendrogram and traditional hierarchical clustering? So we also understand this concept that so traditional hierarchical clustering, we can say it's a method of clustering data points into group based on similarity. We can group them. Okay, it is called hierarchical because it builds a hierarchy of clusters like tree-like structure. Organize them in a tree-like or dendrogram-like structure, right? So this approach, we can say, does not require the user to specify the number of clusters beforehand. Okay, and opposed to non-hierarchical method like k-mean clusterings. There are two main types of hierarchical clustering. First was in algorithm hierarchical clustering, and another one is the divisive hierarchical clustering, right? So agglomerative hierarchical clustering, we can say the most common type of hierarchical clustering. This is right, and each data points we can say start as its own cluster, and clusters are successively merged based on their similarity. So here we can say the similarity is the main concept. As per the similarity, we can structure the data, we can group the data, right? So this algorithm, we can say, continues merging clusters until all data points belong to a single cluster, okay, at the top of the hierarchy. So we can to group them. And another point is that we can also create the dendrogram. That is the another concept of traditional dendrogram. What is dendrogram? A dendrogram is constructed to represent the hierarchical relationship between cluster. So it maintains the hierarchical relationship between cluster. There are a number of clusters in the data points, right? So we have to maintain, we have to construct the representation of hierarchical relationship. It shows the order, you can say it shows the order in which clusters are merged, and the height of the vertical lines indicates the level of dissimilarity at which the merge occur. That means it's always balanced all the data points, right? And it also shows the order it shows the order in which we can see the cluster are merged. So there are multiple clusters and we have to merge them. And the height of the vertical lines. So there is one height, right? You can say height of the vertical lines indicates the level of dissimilarity at which the merge occurred. So this is the another concept of dendrogram. So we can also know that traditional hierarchical clustering is flexible. Why it is used? Because traditional hierarchical clustering is flexible and we can say that it can be used with various distance metric. Like there are various distance metric like linkage method is there, like single linkage, average linkage, computational linkage. So the choice of these parameters can affect the resulting clusters. Okay. So in practice, agglomerate hierarchical clustering is widely used due to its simplicity and interpretability. So traditional hierarchical clustering is divided into two terms that I already discussed: agglomerative hierarchical clustering and divisive hierarchical clustering. And then we switch to that another point that now k-means clustering. So we also know that k-mean clustering and k-mean clustering algorithm was proposed by J. Herrick and M. A. Wagon. That is 1979. This is the they have these two men professors they have proposed. Okay, and we can say we have that set of n distinct object. The k-mean clustering algorithm partition the object into k number of cluster. Here k is that means how many cluster we are going to form. It can be 3, it can be 5. So this number k means k is that number of clusters. K represent the number of cluster such that inter-cluster similarity. There are inter-cluster similarity is high, but the intra-clusters and inter-cluster similarity is low, right? So one common term is intra-cluster and another is that inter-cluster similarity. Okay, and in this I'll come this point. What is intra-cluster and that inter-cluster? And we also just finish this slide. And in this algorithm, we can say user has to specify k. K already told that number of cluster, how many cluster we are going to form in that object, right? And consider the object are defined with numeric attributes. There is numeric attributes. It can be 3, it can be 5, and thus using any of the distance metrics, we already told it's a distance metric to create the clusters. Okay, so this is the k-mean clustering. And we also know that the algorithm can be stated as follows. So we first select k number of objects. This is the process how the algorithm are we can say that how k-mean clustering are going to form over there. So first it select k number of objects at random form. So there is multiple data points over there, right? So they have to create the form with the k number of objects, the set of n objects. There are a number of objects obviously be there, right? So these k objects are treated as the centroid or center of gravity of k cluster. So first we have to identify the centroid. So centroid is the center of gravity, and after that we have to divide the clustering. Okay. So first common example, the key point is the centroid. Centroid is the center of gravity of K cluster. For each of the remaining objects, so I have cluster means centroid. Okay, so remaining objects are there, and it is assigned to one of the closest centroid. Okay, and thus it forms a collection of objects. And first they have to identify the centroid, center of the gravity, the center point, and remaining of the object. They are create a form of another object of clustering, right? So it forms a collection of objects assigned to each centroid. So first centroid is created and remaining objects are there, and this remaining object is assigned to one of the closest centroid. So centroid number is there, right? So how much it should be closer, and other object will be assigned over there, or create a form, create a group, okay, and it's called a clusters. Next, the centroid of each cluster is then updated, or we can say that by calculating the mean values of attributes of each object, right? Then the next centroid of each cluster update. The assignment and update procedure is until it will continuous process, but it can continuous until it reaches some stopping criteria, like how many number of iteration are going to produce, how many centroid remain unchanged or no assignment, because there are different kind of use cases are there for creating the k-mean clustering algorithm. Why we are going to choose the k-mean clustering, right? So there are different kind of business cases there, and as per the business case we have to choose this k-mean clustering algorithm. But we can say a k-mean clustering, and it's a unsupervised algorithm techniques. So we already saw there are different kind of set of algorithms are there, right? So, and you can say the algorithm, there is input, right? So D is a data set, is called, this is a structure or process, we can say, how the k-mean clustering is going to introduce, or how k-mean clustering is going to means they have created, right? So here D is the data set that is containing n objects, and k is the number of clusters. I already told how many clusters are going to produce or going to create. So that is the k is the number of cluster, and steps is that randomly we can choose the k object from D as the initial cluster centroid, right? For each of the object, it can compute distance between the current object and k cluster centroids, right? And we can assign the current object to the cluster to which it is closest. So centroid we have to first understand, we have to first create the center of gravity of data points. Once it is created, there are remaining objects are present, and that remaining object, how many clusters are very close to the centroid, they can be grouped to each other, right? And compute the cluster centers of each cluster. These are the some few key points that we have to measure, we have to understand, like cluster centers, and this becomes the new cluster centers, right? So this step will be repeated 2 or 3 times until the convergence criterion is satisfied. Means how that the process will be continuous until the optimization, the how much optimized k-means cluster that will be formed, that time it will be repeated, because the smoothness, the we can say that that hierarchical clustering concept of smoothness, how much we can get this, and up to this point the process will be continuous, okay? It will going on optimized the data points, right? In a continuous process, and then it will be stopped, right? I hope that I can add some kind of understanding of k-mean clustering, and okay, and this is that I want to share with all of you. And one major important thing also, that I have one example that I want to show. Just a minute. Right, you can say the example of, so you can understood, okay, these are bare minimal data points, there is hard coded data, right? So how k-mean clustering works, right? So you can say that apply k-means clustering algorithm to group, these are the questions. So you have to apply k-means clustering algorithm to group the visitors. Just a minute, I just increase the font size so you all can understand. So you can say that apply k-means clustering algo to group the visitors to a website using just their each one dimension space, right? So what we have to create, you have to apply our k-mean clustering algorithm and to group the visitors, means how many visitors are active in the website as per their age. The age is the key point, right? We have to making the cluster. The values of age are given as follows, right? So this is the age 15, 16, 19, okay? And assume the cluster size. So we can say that K is 2. K value is 2. Means two cluster we have to create, right? And use that Manhattan distance as dissimilarity measure. So this is the distance. One is there are different kind of distance we have to measure, right? So this is the problem statement, right? So you can the simple the forget about the distance, all kind of things. First, we have to understand the problem statement, right? So we have that two cluster, right? And assuming in initial two cluster is you can say 16 and 22. Why? That we can see this is a table and iteration is that 15 C1 16 C2. So there is different kind of distances, right? So this is this is the age, right? 15 and CL 16 C2 22, and we have to create that new centroid. This is the new centroid we have to calculate. This is the table of the age and this is we can say that cluster 1, cluster 2, okay? So we can data points is 15, 15, 16. That is the age of, and we have to nearest to the cluster 1 and C1, and remaining data points are nearest to cluster 2. Cluster 1, cluster 2, okay? C2. So distance and new centroid are calculated as follows. So that new centroid C1, this is C1, right? So C1 and C2, C1 is 15.33. That means we have to create the sum mean. So first 15 plus 15, this one 15 plus 15 plus 16 by 3, okay? And then the value will be 15.33 over here. We can say this is a new centroid. So only this table, na? Only this, just a minute. So you can see that is only these three data points. We have the centroid 15.33, okay? And this is the closest centroid. And then we have the other data points, right? 19 plus 19, 20 up to the 65. And we have to first create the means average. Average we have to create, right? And that is 36.25. And same thing, the data points will be changed over here. So this is the first iteration. So first points, first optimization part of the data. So first, this is the iteration 1. The centroid will be 15.33. This is the second iteration, and the centroid will be, you can see that centroid gravity will be changed over there, right? So 18.56 and 45.9, okay? And then third iteration, we can get different kind of centroid, right? Up to 4 iteration we have to take, right? And no changes between iteration 3 and iteration 4, right? So there is no, as per many means iteration 3 19.50 and also iteration 4 19.50, okay? So has been noted as the same points have been assigned to each cluster in consecutive iteration. Therefore, we have to stop over here because we got the optimization and the iteration level 3 and 4. So cluster 1, we have this value 15, 15, 16, 19, and cluster 2, we got that optimization value of that part, right? So this is that way we have to apply this is the one example of, we can say that k-mean clustering algorithm. We have to identify that centroid, and you can see that centroid I have calculated in this way. So here 15 plus, we all add the data points. There are 3 data points, 15 plus 15 plus 16, and nearest to cluster 1. and remaining data points are nearest to cluster 2. So nearest is cluster 1 and remaining will be the cluster 2. So that is the reason this is the box, right? Nearest and rest of the cluster 2, cluster 1 and cluster 2, okay? And this is the distance you have to understand, right? And also we have to take some kind of like already is told, right? What is cluster analysis? So cluster is collection of data objects. We can say it's a similar to one another within the same cluster. This similar to the objects in other cluster, right? And cluster analysis, why it is important and what is the key points. We have to finding the similarity between data. K means clustering is one of the algorithm, but cluster analysis we have to understand first, right? So finding similarity between data according to the characteristics that we have found in the data, we have to group them similar data objects into cluster, right? And it's a no class or there is no defined class or present, so it's totally unsupervised learning algorithm, we can say. And we have to know that classification and clustering, some kind of difference we can say. So classification is a supervised learning. It's not, clustering is totally different than the classification. So I have determined some kind of means differentiation point that is predefined. Unlike classification, you can say cluster are not predefined because there are no labels are there, right? And so that is the reason cluster are not predefined. And usually in classification you have a set of predefined classes. So classification is a label, is working the label data set, means supervised learning, right? So predefined class are present, but in clustering there is no predefined class because clustering is a use case of unsupervised machine learning approach, and classification is a example, or you can say it's a use case of supervised learning. So that is the reason in classification they have some predefined classes, but in clustering there is no any predefined classes are present, okay? And we can say label and training also, these are approaches and predefined method, right? And label and training, we can say clustering does not use label data. You already mentioned unsupervised learning not dealing with the label data or a training set, right? Does not use, but classifies new data in classification. Whenever we discuss the classification model, so classification new data based on observations from the training set. There is no training record, there is no training set, there is no label data in the clustering method. But in the classification, the observation will be there. The classifies new data based on the observation from the training set, right? The training set is labeled. So that is the reason classification is a problem statement of supervised learning. I repeatedly told these things, right? Algorithm, the popular algorithm is a k-mean clustering and hierarchical clustering, dendrogram hierarchical cluster, right? The most popular algorithm. And in our this problem statement means in here we have to create a k-mean clustering, optimized level of k-mean clustering that we have to create over there, right? And k nearest neighbor and decision tree algorithm are most popular in classification algorithm. K means is usually means used for the clustering technique, hierarchical clustering, and K means clustering. They are the popular algorithm of clustering method, and K nearest neighbor and decision tree. These two algorithm, this is popular for classification and this is popular for the supervised learning method, right? This is not that unsupervised method. Complexity less complex as compared to classification, and highly complex, obviously the vice versa, highly complex as compared to clustering. So this I hope I have had some kinds of idea of clustering and classification techniques, clustering algorithm and what is cluster analysis, right? So fine, whenever we are going to produce that, first we have to understand, is there any label data or not? If there is no label data, no predefined data set, no predefined training set, so obviously we are going to use the cluster technique, clustering methods, right? We are not going to use that supervised learning mechanism, because cluster analysis is mainly focused on unsupervised. There is no category of data set, right? And then we have to create one by one techniques. So first, k-mean clustering and hierarchical clustering, these are the techniques of clustering analysis. And we can say that typical application. So this one example that I already told. So as a standalone tool to get insight into data distribution, so you can say this is the group of data, right? The different color. It's a group of data, right? So first is intra-cluster. Intra-cluster means within. Inter-clusters means between two. You can see the arrow points, right? This is one of cluster, this is one of the cluster, and in the between the distance, right? This is the arrow sign. You can see the arrow point, right? The inter and intra means within the cluster. Intra-cluster distance are minimized because within the cluster they have to identify the distance, right? And inter clusters they are maximized because group of clustering, we have to create a subset of data points. Two data points are there, and within the two data points we have to find, we have to measure the distance. So this is the first we have to know this thing, the inter cluster, another is intra cluster distance, right? So this is the point we have to understand. And what is not cluster analysis? Why some use cases we are not going to treat? This is the cluster analysis. So simple segmentation. Segmentation also dividing part, right? So dividing students into different registration groups alphabetically. But this is not the cluster analysis. Simple segmentation is one of the example. This is not coming under the cluster analysis. They are dividing students into different registration groups alphabetically by last name. This is simple segmentation, but not clustering. We are dividing, but is not the cluster. Clusters is different thing. Segmentation is different thing. Result of a query, right? Here also creating group, right? Group are a result of an external specification. Clustering is a grouping of objects based on the data, right? This is also not treated as a cluster analysis. Supervised classification. Classification algorithm is not coming under the cluster analysis because k nearest neighbor and decision tree, they are measured popular algorithm of supervised classification, but not in the cluster. Associated analysis, right? Association analysis enables you to identify items that have an affinity of each other. Here we also create like market basket analysis, association rule we have to create. So we are not going to discuss elaborately on the association grouping, but this is the this is the association analysis, association rules of techniques. That is the different thing. But in this point, or we in this business case, we are not going to treat this is our clustering techniques, right? Like grocery stores and online merchants use association analysis, like market basket analysis. There is also clustering, grouping that customer segmentation, right? But it's not treated as a cluster analysis. Okay, and we also said that we have produced the association analysis. Why? To strategically organize and recommend product. Here we also create the group for recommend product as per the market basket analysis, right? Whatever the product I have choose and same kind of product they are going to add in my mobile application, right? Or they have recommend this. Here they also group, right? But this is not the example or not coming under the cluster analysis. Okay. So you can say that clustering, definition of clustering problem. So you have the database like T1, T2, Tn up to that clustering of n tuples. That clustering problem is to define a mapping where each T1, right, is assigned to one cluster. So one of the cluster is assigned to each other, right? And here C is equal to C1, C2, and Ck denote a set of cluster. So this is the set of cluster. We have to first establish the condition, establish the definition. So solution of a clustering problem is devising a mapping formulation, right? The formulation behind such a mapping is to establish that a tuple within one cluster is more like tuples within the cluster and not similar to tuples outside it. So in this way, we are going to define that cluster mechanism, and we can say that we also add some kind of data set, and in this way we are also calculate the clustering algorithm problems, right? Like each ti assigned to one clusters, and we have to find the similarity, and with the similarity in this field of cluster, the similarity plays an important role. So you have to creating the similarity in the different kind of distance algorithms are also be there, right? And the similarity and dissimilarity measures. So similarity between two objects, like two images, two documents, two records, is equal to, means we can say, numerical measure of the degree to which two objects are alike. So we have to convert it in the numerical measure, means number. Dissimilarity measure of the degree to which two objects are different. Some two images, right? How much is close? So we have to identify these things when the numerical measure, means number, with the help of number. And dissimilarity, we can say that how two objects are different. This is a dissimilarity. So both similarity and dissimilarity also termed as proximity, right? We also understand similarity and dissimilarity. These also termed as proximity. So usually you can say that similarity and dissimilarity are non-negative numbers. Okay, there are non-negative numbers and may range from 0, high dissimilar, or to some kind of finite infinite value, right? So these are the conditions that we have to establish that problem statement of when are going to create the clustering problem. So dissimilarity and similarity also termed as proximity that I told. So frequently the term distance, right, is used as a synonym for dissimilarity. So in fact, it is used to refer as a special case of dissimilarity. So distance we have to identify or we have to measure, right? And the similarity and dissimilarity measure, that we also told that similarity measure, numerical measure, or how like two data objects are, is higher when objects are more alike, often fails in the range. There are some kind of ranges there, 0 and 1. And dissimilarity measure, that we told, numerical measure of how different two data objects are. This is a dissimilarity. How different two data objects, that is called the dissimilarity measurement. So lower where objects are more alike. So this totally different for the similarity, right? Upper limit varies. Proximity, we also told that is refers to a similarity or dissimilarity. And there are different kind of techniques of measuring the distance. Micron distance is generalization of equivalent distance. So equivalent distance is very popular distance algorithm, that where you can see that x and y, this denoted this bar, right? So r is a parameter and n is the number of dimensions, attributes, right? And x, k, y, k r. So these are not coming to all of the things. So I have the different sessions on that. So I just told this kind of, you just unfamiliar with the name equivalent distance, equivalent distance, right? So this is called the minimum distance. So these kind of things we have to understand, obviously, and there is a variation. And I also created this kind of techniques, that example, right? So the other session that we have to discuss this thing. So this all the take we have to understand these kind of things, and I hope I have added some kind of means learning, or you can understand these things, right? So this is the methods that Jacob distance analysis. There are different kind of techniques are there, and in the I have stopped over here, and if you have any kind of discussion or any kind of issues or any kind of any questions, so please let me know. I will help you there. And these all kinds of things I am not going to discuss in this session, because these are totally different sessions, and I only focus to the k-mean clustering part over there. But apart from that, there is different kind of analysis part that I will cover in the different session. And in the next session, that I'm going to create that coding part, how the problem statement of the Irish dataset that I'm going to adding. So before that, I thought this kind of some discussion or some context that we have to set before going to coding, right? So that is the reason I have taken this session, and I hope you have some kind of understanding on that. So if you like, please subscribe my channel. Please add some kinds of comments if you not understood, or if you like or not. So that can help me, and you all know that in this way we can grow and learn together. And if you could subscribe my channel, so obviously it will boost my confidence more, and I will provide some more good high context content obviously in front of you. And thank you everyone and joining the session, and thanks for attending all the session, and thank you obviously listening to me. Thank you everyone. Bye.